Hello guys, in today's live stream, we will look at the Big Mart dataset, sales dataset. It's a regression problem. Today we will create a data science project of end-to-end project of regression model. Let me go back to this dataset. We are on Kaggle. For downloading this dataset, we have to click on this download button. Our dataset is downloaded. Now for unzipping it, we will use this. So here is our dataset. Now create a directory called sources prediction, and here I paste this CSV files. Now head towards VS Code. Initially I will initiate the git init command. Oh sorry, git init. Okay. Now git add git commit -m. This is our initial commit, so I will type message as initial commit. Okay. Now we can start working on our Jupyter notebook. We will create a Jupyter notebook called notebook.ipynb. Okay. Now we will import necessary libraries like NumPy, Pandas, and Matplotlib and Seaborn. Okay. Import NumPy as NP. Import Pandas as PD. Import matplotlib.python as PLT, and import Seaborn as SNS. Okay. Let's take more time. Oh, now our aim is to import the dataset. Let me import CSV files like df is equal to pd.read csv. Our file name is train.csv and df.head. So okay, nice. Now similarly we import our test dataset file. For this we will type test is equal to pd.read csv test .csv. Okay. And one thing, we always use markdowns, like importing necessary libraries. Okay. And here importing our dataset, importing CSV file. Okay. Now we will perform EDA for this set, our DF dataset. Let's check what's the shape of our dataset. Shape of dataset. For that we will use df.shape. Oh sorry, df.shape. Yes. So we have 8,500 8,523 rows and 12 columns. See, uh, let's see what information about the columns. So we will see df dot columns. Columns name. So these are columns name like item identifier, item weights, item fat content, item visibility, item type, item MRP, item outlet identifier, outlet establishment year, outlet size, outlet location type, and outlet type. Okay, and item output sales. So this is our target variable, and these all are our independent variables, or you can say features. Okay, so for a moment we will get more information about uh, our data set. Let me type df.info, and here, oh sorry, we have to use parentheses also. Okay, so here we can see our item identifier is of object type. Okay, wait. Uh, okay, this is a float type. Okay, this is our object float. This is okay. So now we will initially check is there any null values or not. Okay, for that we have to use df dot is null and dot sum. Okay, oh my god, so we have null values. So item weight is a float type, yes, and our outlet size is object type. Okay, let me see df of let me see how was our data set. Our item weights, these are for sorry. Okay, and outlet size. Okay, let me see what are the unique values of our outlet size. Outlet size dot unique. So there is four values: medium, high, and small, and none values. So we will replace none values with a fourth category. Can we do this, or how? Okay, now we will fill this category with the fourth type, that is NaN. Okay, for that we have to do df size is equal to df outlet size dot fill Na with value with value NaN, or we can say no info, no, we will type NaN. Okay, now we will check is null dot sum. Okay, so these are become 0. Okay. Now we have to fill any values with item weights. Let me see what's the median of item weight dot median. It's 12.6 and what's its mode item weight dot mode. Okay, let me also see what's its mean also. Then I think we will use median for filling any values. Goes mean. Yes, we will take median value. Okay. Now df is df item weight is equal to df item weight dot fill na with d. Let me copy and paste it here. Copy and paste it here. Okay. Now again we will see in our file is there any null values or not. df dot is null dot sum. Okay, so our data set does not have any null values. Now we will see is there any duplicate value or not. df dot is duplicate, I think, or what's the command for that? Duplicated. Let's check. Dot sum. No, there is no duplicate values. Or we can do df dot drop duplicates. This will automatically drop the duplicates value. Duplicates, okay, and hit enter. Great. Okay, this give me non-duplicates value, which is 8523, which is same as our data set. So there is no duplicate. Okay, let me again cross check it. We can see from documentation pandas dot drop duplicates. Okay, if we have to save our data set as df, then we have to use in place is equal to true. Now if our data set have duplicates value, it will drop that value, duplicate values, and save that data set in df data frame. Okay, so hence now we will see again. Now we will see what are unique values in our columns of our data set. Okay, for that df dot columns. No, wait, we can create a loop for that. For just for a second, let me see. Let me again info. Sorry. Now we will check the unique items present. You can say unique values present in all object data types column. Okay, for that we will create a for loop for I in d, or we can say for call in df dot date, sorry, df dot columns if d type of or df of col dot d type of is equal to object, then print col also print, sorry, not print, we have to check the unique values. Okay, df of col dot unique, and then df of, then also we want to print the length of how many unique values are there in our column. Okay, for that again unique and then complete parenthesis for length is. Let's try this. Okay, so item identifier has 1559 unique values. Okay, we can I think we should remove this. Okay, and here is item fat content. Okay, you can see here देखो, here you can see there is low fat, and LF, which means we can create, we can merge them in a single category, and regular and regular similar category. Okay, cool. And in item type we have dairy, soft drinks. Okay, these kinds. Okay, in our outlet identifier we have 10 unique values. Okay, in our outlet size, that is medium, high, small, and NA. Okay, outlet location type, tier 1, tier 2, tier 3. Okay, outlet type, it is of supermarket type 1, type 2, grocery store, or a supermarket type 3. So now we will do, we initially drop item identifier column, because I think we do not need this column. Drop, let me go from here. Its axis is 1. Oh, sorry. Let me put in place is equal to true. So our this data frame save in df data frame. Okay, and if we see df dot head, you can see item identifier column is removed. Yes, you can see here item identifier column is removed. Okay, now we will do we will change reg with regular in item fat content. Okay, df of item fat content, we can use replace method, I guess. Let's try dot replace, or we can use replace values to replace with value. Let's try this. Okay. No. Oh, yes, we can also use where, but let's see if we can use this. So we have to replace reg with regular, I guess. Yes, regular. And see df dot which column is this? It is which column it is? It is item fat content. Item fat content dot unique. Yes, here we replace reg with regular. Similarly, we replace low fat and LF with low fat. Okay, let me just copy paste it again. Oh, sorry. Or oh my god. No worries. This will create this will not impact our data frame because it is already done. You can see here regular is reg. Oh, sorry, reg is regular. Now we will do capital LF with low fat and small low fat with capital. Okay. Oh, so we do not need this statement. We can delete this and hence we will run this. Yes. So you can see here this is low fat and this is regular. Okay. Now I think we should do some visualization. Let me wait. We can use gf.describe about our sort data types. Here we can see our item weight is mean this, item visibility minimum is 0 and maximum is 0. Okay, about MRP we can see 31 and okay, and output establishment here, outlet step. We can do, we can convert it this into age of outlet. Yes, let me see, df of outlet establishment here dot head. Okay, yes, we can create a new column df. We called it as outlet age. 0 2023. Yes, then df dot head. Here we can see outlet age. Okay, cool. Now we can drop this outlet establishment here. Df dot drop outlet. Wait, we can copy paste this and x is equal to 1 and in place is equal to true. Cool. Now we can, what we can do, should we also remove this outlet and identify column? Let's, for now we do not remove this column, we can create one hot encoding for this. Now we will see item type. Can we create a head, or you can say main category for these subcategories? Item type dot unique. So dairy, meat, soft drinks, fruits and vegetables, household, baking goods. Okay. Snack food. Can frozen food, breakfast, health and hygiene, hard drinks, canned, breads, starchy food, others, and seafood. I think we should take as it is. No, no changes required. Now we go towards head towards visualization part. For that, let me item weights. We can visualize. We can create a his plot. However, weight distribution weight is distributed. Item weight is distributed. For that, we will create dot fit size. I guess. Wait, just paste. Data is our df axis item weight. Let me cross check. Yes, it is item weight. And as plt dot title item weight distribution. Just do this. Oh, I think we fill any value with the 12.6, so that's why we will see there is a high gap in between. Okay, that's why there is a high gap in between. You can say all these lines and 12.6 column. Okay, now what we can do? Okay, let me see how many values are regular fat items and low fat items. Okay, for that I will use for that I have to use, we can say, count plot. Yes, we can draw a count plot for that. Count plot for, again, data is our data, df, sorry, and our x value is our item fat content. So dot title, and our here title is item fat content distribution, or you can say Oh, oh, sorry. I use listen, I have to use PLT code. Okay. Here you can see. Here, regular fat content items are 3000 and low fat content items are higher, around 500, 5000. Okay, that's nice. It means people prefer low fat items as compared to regular fat, which is healthy for them. You know, again, but we can visualize more. Item visibility. We do not explore this. Let me see what inside this. Item visibility. What it's saying. Just forget it. More about it. We can see how our items are distributed in item types. Okay. Again, we can copy this. Item type distribution. I think we have to create 90-degree. We have to do this with vertically. Note that there is plt.x tick, I guess, or get to set the current tick locations and like move the let me know. This is for labeling. We should use ChatGPT. How to convert X. How to rotate X labels in matplotlib. We have to use X-tick. Okay. Rotate for okay. Rotation. There is rotation. X-tick. And we rotate it with 90-degree. Let's see. Yes. Now it is cool. We can see there is fruits and vegetables, snack foods. Okay. There is 650 around dairy products. Okay. Can we do something with this? Can we? Can we see item outlet sales? Can we see visualization of how outlets, which is you can say outlet identifier, distributed with sales? How much sales? Okay. I think we can do this. Yes. we have to create visualization in which we will see how much outlet sale, how much item this outlet sells. Okay, for that I think we have to use legend for that. SNS dot. Let me use his float, and then data is sorry data is dx is, we can say x is this. Okay, I'm sorry, this will be our legend. We have to use this item outlets. I think this will, I'm going wrong way. This will give me wrong visualization, but let's check what we get. Legend. Let's see what we get. Oh, we get something else, I guess. No. What we can do for this? Let's take the help of ChatGPT. For this, we can copy this entire thing and paste it here, and then type our question. Oh no, we do not want it to upload. What we have to do, we have to code to visualize sum of item output, sum of item outlet sale, sum of, or you can say total item outlet sale with outlet identifier. Wait, I guess we remove this outlet establishment here, but here how we can see, always forget it to remove. No worries. Now we can drop this. Just a second, let me do this thing first. Till then, I will stop, or we can do this. I am not writing markdowns currently, because when I will train my model, it will take some time for training, and at that time, I will create markdowns, or we can say I will highlight or comment the things. Okay, I think we can. We can here we can see, but how here in I use that one, but how, why this is not Here is not outlet establishment here. We can see, but why I'm getting there? Just okay. We have to group by that with the total. Okay, and then we have to plot what. Okay, let me copy paste it. So this will what they do is sales by outlet. They group by the they group by the data, or you can say column or data frame with the item outlet sales column. Okay, and then they plotted this. Nice. Here we can see again we have to create 90 degrees. We have to rotate this by 90 degree. For that, copy that command and paste it here. Here you can see. So we can see our outlet is 10 and 19 are least performing. 10 and 19 are least performing, and our most performing outlet is outlet 27. Okay. Now I want to visualize outlet location type, outlet type. I think we can do same this with outlet size and outlet type and outlet location type for with item outlet sales. Okay, I will do the same process as we do with this. Now we group by this by which are our outlet size. Okay, we will group this by outlet size. Sales by outlet size. Outlet identifier. No. Outlet size. Total sales. Total item outlet sales by outlet size. Okay. This is value, I guess. Let me wait, what happened to this? Hmm? Oh, that got this. Used it here. So this is our new visualization. What happened to this? Oh, we created a blunder. Here we should type total oh sorry, item outlet sales, and we typed outlet size here, and here instead of outlet identifier we have to use outlet size. Now yes, this is our required visualization. Here you can see total sales in, okay, thousands, okay, cool, cool. This is not in thousands, this in millions, okay. We can see medium outlet size sales are maximum. That's okay. I think outlet location type also give us nice visualization, or you can say more information about our, again let me copy paste which is what's our column name, outlet type size, no, not type size, outlet location type, outlet location type, and here our outlet, we can say outlet type, or we can say outlet city, log type, outlet location type, total sales, yes, total item, outlet sales by, total outlet sales by, outlet location type. We can see our tier 3 cities are more, we getting more sales from tier 3 cities as compared to tier 1 and 2. Yes. Outlet type. That is outlet type, okay. Just remember outlet type. Total sales by outlet type. This will give us, okay. Supermarket type 1 gives us, giving us very high sales as compared to grocery store. Okay. Let me now do create a heat map of correlation. How every features is correlated with our dependent variable, or we can say target variable. For that we will use df dot core. No, what if of heat map is only created when our column data type is float or int. But in our dataset we have object data types also. So for that we have to create a for loop for call in. We can do nothing. We can create a list that is empty list codes in df.calls, and if df of call equal d type is not equal to object, then we will append that variable in column name in codes list. Yes, we can do this. Okay, let me see codes. Here we can see there is 5 variables. Okay, now let's create a visual heat map. For that we have to use df of calls dot correlation. Okay, and we have to save this in a variable called core, and now sns dot heat map, and data is our core, and other variables like same annotation we will do it true because we want to see the values how correlated it is. prt dot title correlation of correlation features per variable. We can say just an target variable. Here we can see, oh, this is our item output cell. This is our target variable, and these all are, you can see how correlated are. Item IMRP is correlated with the item outlet sales, but item visibility is not so much correlated, and item weight is also negligible correlated, you can say. It's if we can compare, this is close near to 0. We can we can remove this feature. Okay, and also we can remove outlet age also, because this is not correlated with item outlet sale. Let's try. Now we can do what we can split independent and dependent variables and then group these columns, or we can do not remove these columns and train our model, and after that we will check by removing these columns and again train our model and compare the results. Compare the results with with these columns, and after removing these columns. Yes, we can do this. Okay. Then initially we have to do one hot encoding for this df. Select this. If we do df dot columns minus calls, what we get? I thought then we have again create a for loop for that for one hot encoding. That we have copy this and obj. Now we append, sorry, is equal to. Now we will append these column name into object list. Object dot append. What we want to append? Cool. Okay. Cool. Now we will do one hot encoding. For that we can use pt dot get dummies. We can save this data, and for data it we should df of obj, and also we want to drop first column, like in our category, if there is two columns or you can say two unique values, then we want to go first to solve cursor dimensionality. If we do not remove that, this will give us or you can say this will affect our model. Drop first true. Let's check. Dot as type int, so we get our values in 0 and 1. Yes, so it comes 33 columns. Okay, we can do one thing also. We can append this in our df folder, and sorry, in df data frame, and then see correlation with our dependent variable. If there is highly correlated with it, we can something. Let's check. Let me we can save this in whe. Okay, and then we can create a new column. Df dot 1 is equal to pd dot concat. Will concat two data frames. One is one hot encoding, that is OHE, and one with these columns. Okay, so we will concat OHE and df data frame with calls or call, what it is calls. And how we want to concat this, we have to give a list, and for we want to concat this with x is equal to 1. df 1 dot head. Let's see, or we can use df dot shape, because we know our data frame values is around 8500. Yes, it is concatenated correctly. Or we can df1 dot head. Here you can see. Yes. Also, we can do scaling. I think first we have to do split into independent and dependent variables. I will save independent variables in variable x df dot drop. My target variable name is item outlet sales. Okay. X is equal to 1. Yes. And then try to see this. Wait. Oh, I have to use df1. That's why I'm saying why I'm getting values in object, or you can say string data type. Yes. Yes, this is my desired output. Okay. Now saving y is equal to df of what is item outlet sales. Item outlet sales. Nice. Now we can do scaling part. So there is we can use two scaling methods. One is our standard scaler, and another is our min-max scaler. Standard scaler will convert our column into where into a condition in which our mean is 0 and standard deviation is 1, and min-max scaler we get our output values into the in range of 0 to 1. So we will use standard scaler. Let me import that standard sklearn dot model selection, import standard scaler. Yes, let me initialize it. Scaler is equal to standard scaler. Yes, scale x. Oh, sorry. Uh, Before that, we have to split our data into training and testing part. Okay, let me remove this train test split. Let me import train test split from scikit-learn dot which I guess this is also model selection. Import. Let me import train test split and then x train x test y train y test is equal to train test split into x comma y, and our test size will be, we will take 0.2 and random state 10. And you can see this random state is nothing, just for like if we again split this you can say data frame, this will give us same output. So you can put any values in here. You can say 10, 11, 12, anything. This will split. This is just for, it will split in same you can say you can say this will let me do let me show you like extreme. Here you can see from here, and if I again split this data with same random state, then I will get same extract value, same variables. Here you can see our first value is 78.49, and here first value is 78.49. Similarly 56.117, 56.117. Here you can see. Now we can delete this. Okay, let me check what's the shape of extract dot shape. Okay, around 7,000 columns. X test dot shape. This is now we can perform scaling. Now what we can do, we will use fit and transform in X test. X train scaled is equal to scale dot fit and transform in X test. X train, and X test will be X test scaled will be here. We'll use just transform X test. Nice. And train. Let me see my first scale models cannot import and name. I think let me search where it is. Standard scalar. Oh, it is in pre-processing. Okay, sorry. Pre-processing. Now here we can see our values is between negative. Okay. Now we can train our model. For regression model, we can use linear regression. We can also use lasso, ridge, and elastic net for this problem. Also, we can use decision forest and decision tree. Also, random forest and decision tree, and linear regression. We can also use boosting techniques like gradient boosting, and also we can use SVM. I have a list of algos. Let me see. With their hypercurrent. Yes, this is. So let me copy this thing and paste. So these are a list of regression models, and let me import these, and also these are algorithms. We will play with this for a moment. Just copy these things. I think we also have to import shuffle split. Shuffle split. Okay. there is a algos dictionary in which we have linear regression, and in linear regression this is the index, and this is, oh sorry, this is our key, and this is our value. And in our value also we have a value is also in dictionary type, in which model is key, and model name is key, and model is value, and parameters is key, and dictionary is our value, you can say. In dictionary we will in params we will give our parameter, or you can say hyperparameters, for hyperparameter tuning. We will define these multiple all regression models, and then we defined a empty list, that is scores. Here we will split our data into 5 splits, and our testing size will be 20%, and random set is 10. So we will use grid search CV. Okay, so we let me give you the overview what will happen. uh, Grid search CV. You can see from here. This is, I guess, 10 folds, but we will do this by, or you can say we will convert our, here you can see, here this is of this data split is in 4 parts, but we used here 5. So our data will split into 4, or you can say 5 parts, and for one part we will use this is as test data, and else as a training data. Then again we will use take next, you can say next quarter, or you can say second fifth values of our test these values as test data, and remaining as training data. Then next values as test data, and remaining as training data. And we will this will happen for 5 iterations. Okay, and for in our scores list we will append a model with their algorithm and best score, what our model will get with the best score and best parameter, which it get for which best score it get from which parameters, and we convert this score into a data frame. Let me know. Let me also import elastic type. Elastic net is not elastic net is not important. From scikit-learn dot elastic, sorry, linear model, import elastic net. So elastic net is like we combine lasso and ridge regression in elastic net, you can say. That, okay, sorry, here we can elastic net net. Let me also do comma here. Yes, here model is our elastic net we defined here. Okay, parameters what we can do, we can define alpha values. Okay, default value is one constant that multiplies the penalty terms at default to one. Okay, I think for this situation we have empty this variables. Okay, for decision tree regression, our criteria is squared error, MSC, absolute error, poison. Okay, for SVR, I think we can define here kernels in SVR like poly and something else. Here we can define poly or yes. And let me convert this into a list format. Note in dictionary. Cool. Random regressor. And I think this will take a lot of time. So, what we can do? Let's see. Let me run this and start. Till then, we can highlight or we can say, oh sorry, you comment our so imported CSV file. Okay, shape of column name, df code, df data frame info. You can say data set info. Checking null values. Null value count. Filling null values of column df outlet size of column outlet size with NaN. Filling null values of column item weight with median value. Okay, checked for duplicate value. Checking for duplicate value. dropping duplicate values if it exists. Again info. Columns with object with unique values and number of unique values. Dropping item identifier column. Here we can see we got an error. Let's see what we got. We got error in X should be a square kernel matrix. I think for R SVR or for which algorithm? I think for SVR, yes. For SVR, SVR pre-computed. Oh, sorry. Let me. For which model we got this error? Okay, we see this. I think again we have to take the help of ChatGPT. This will explain much better in a much better way. ChatGPT. X is expecting square kernel matrix. Yes, it is of SVM2. Okay. Let me remove pre-computed. Then I guess we can run it again. Let's go back to our commenting section. Here we can write here. Converting, or you can say replacing. And one more thing, whatever we are doing in this training data set also, or we can say DF data frame, we have to do same things with that CSV data, test data set, that is our test.csv file. We will do when we select our model which is best performing, then we will do for test.csv. Okay. Let me where we are replacing reg with regular. In which column? In item that content column. Okay, just replacing low fat, comma LF, or we can say and with low fat. In item fat content column. Okay, just a minute, let me see. Is my stream is smoothly run? Not. Control shift. This, oh, it's working smoothly. So here we creating new column. New column. Outlet age, which is equal to 2023 minus outlet establishment. I think my spelling is correct. Yes. Year. And then dropping let me copy this column, checking for unique values. Here we can wait, we done a small mistake here. Let me check. We forgot to, I think we forgot to scale our values in training part. Let me see. I think I give, yes, I give X here. I have to give X to scaled here. Let's see how our model will perform. But in random forest regressor and decision tree regressor, there is no change in if we use scaling or without scaling, because this will creates you can say epochs or branches. But in linear regression, it will affect in elastic net, in lasso, in ridge, in SVR, it affects, and also in gradient boosting, it affects. Let's see. item set content is my, you can see, yes, my models are trained. Let me create here. Oh my god, I'm getting very bad score, around 60%. Let me try the same thing with xscaled also. Let me define xscaled. Xscaled is equal to scalar dot fit transform to x, and then use xscaled. Okay. So I forgot to type plt dot show. We can do this. Item set content distribution. Also, we should you can say give comment or our opinion on this visualization, this all visualization. But currently, I'm not doing this. But we have to do like after every visualization, we have to give our comment. What we retrieve, or you can say what we get. This is our incorrect incorrect you can say visualization. We can delete this here, but we got total total item outlet sales. Okay, total outlet sales by which outlet identifier. Let me copy this because we have to use this multiple times. Okay, now by outlet size, now by outlet location type, and now by outlet type itself. Cool. Columns with object data type. Correlation, relation, you can say heat map of independent variables and with dependent variables. Dependent variable. Okay. sorry, with without object data type, and with object data type is here. Performing one hot encoding, one hot encoding, encoding of categorical data types, categorical data, or you can say categorical columns. Okay. Concatenating OHE with DF with columns without object data type. DF columns without object data type. Okay. This is our independent variables. Independent variables. Dependent variables. So our training is finished. Let's see what we are getting around the same value, around 60%. Okay. Then we will go forward with the gradient boosting. Let me but we can else do. We can again try to hyper tune this using from scikit-learn.ensemble import gradient booster regressor. Is there any CV? Let me see. CV. No. We can search. Sorry. Hyperparameter tuning. Okay, just a second. Let me see how we can tune gradient boost. We can and we can use these multiple loss functions. We can also play with this learning rate. Okay, and we can also play with these n estimators. Subsample. Okay, this two. Minimum sample split. Okay. Maximum depth of because in gradient boosting it will create binary trees according to information gain, and that's why there is a minimum weight fraction and minimum weight fraction of leaf and maximum depth. That's why there is this criterias, you can say variables, because this creates a binary trees random set. So main hyperparameters are: one is loss, learning rate, n estimators, number 3, and number 4 is criteria. Okay, let's see. N estimator, uh, n estimator, learning rate. These are first. Number first is loss function. Let me select squared error, and for you can see learning rate. Let me sorry, 0.01, and let me our fourth and our third criteria is square. Let me take square error. What means square error? Let me take another one. And what's our fourth hyperparameter? It is n estimator. Let me take it as 50, or we can say 5. Let's take it as 50. Then now we will fit this on our X train scale data. For X, sorry, Y train strain, and for prediction, or you can say for score. Let X test scalar, comma, Y test. Oh no, this is performing very bad. I think I have to do it as 50. This is performing better. Again, let me see. It is for 50 and learning data is 0.01. Let's see. Yes, this is performing better. And as for instead of squared error, let me try it instead for mean squared error. Let me try it for squared error. Oh, sorry, squared error. Here again 61. Then let me play with this loss function. There is, I guess, hyper Let me see. 4 possible values. Let me copy here. Absolute error. No, scaled error is performed better. Let me try sugar. Again, scaled error is performing better than this quantile. Oh, this is very horrible. Scaled error. And let me try to change an estimator. Let me do it for 100. What we get? See. Again 59. Let me try it for 75. Again 60. Then I think we should use this as 50. Can we again play with this learning rate? Let me take 0.2. It is decreasing my accuracy score. With this, let's take this model and carry forward this. Now again, let's try it with the we can remove some features. Let me do this first. We can say commenting first, splitting our data into training and testing data. Perform normalization. We can remove this because we get our best parameter, or you can say best model, which is performing best. Okay. Cool. Now what else we can do? Train our model. Now defining x. Now we are defining x with 20 features, you can say, or we can say most correlated 20 features with our you can say variable target variable. What we can do for that? I think I use somewhere that I think I done this in which project I I think social media classification. There I used we have to take help of we need to take help of ChatGPT. This. Hmm. How to get sorry top 20 most correlated features with target variable. I think this will create a correlation matrix, and there it, here we can see yes. This thing we already have done, and after that this stated an absolute. So okay, okay. Let me again find the correlation matrix. Core of y we can say with df1 dot core sorted features correlation matrix. Let me initially define this. Oh, sorry. We have to use code 7. Here we can see how this item fat content regular is correlated with this column, and this value also. Now we want to sort this by score, and then copy. Our correlation matrix name is core y, and our target variable name is outlet, total outlet sale. Just a second. Let me see. It is item outlet sales. We have to give this in a string format. And now we will get the we take absolute value of this and then sort it as descending order, or we can say we take this column uh, we took this column and uh, filter this, or you can say sort this in a descending manner, so that we get our highest correlated value, we get our values in highest to lowest, and we will take first 20 variables from that. Let's see. Here you can see. Now we will take just first 20 variables and then train our model with these 20 variables. I think 3, 6, 9. Let's see. Then first we will take first 20. first 20 variables, and after that we will try for first 10 variables. How much difference we will get in our score. We will check from that. Okay. Save this in a variable. Top, or we can do here also top 20. Top 20 features. Cool. But this is in a string form, a series format. This is values and this is the index. So for selecting the index, we have to use top 20 features dot index. Okay. Let's do df. It is, I think, df1. Or yes, df1. Df. Let me define a new data frame. It is df2 with df1 of with columns, not with the list of columns. Top 20 features dot index, because our columns name are in index. Okay. df2 with, here we got our 20 columns. Cool. And now again we'll split this into you can say independent and dependent variables, and again perform uh, training. Again we will train our model. Cool. And let me do one thing. So let me split this into x and y. Again, x is equal to df2 of, let me drop the column. Column name is item, outlet, sales. X is equal to 1. Okay. There is no need to see the x, or we can, let's see. Y is equal to df of item, outlet, sales. Again we form a printer split. We can copy paste that thing. Again normalize it. We have to standardize it. And then we have to train our model. Let's see what we get. See, we get around you can say 61% accuracy, and with here we can see 61.04%. You can see we do not lose so much uh, uh, you can say accuracy score, but uh, our number of features, or you can say independent variable, become very less. I think it is enough for today. Tomorrow we will try to train it with 10 variables and then see which will perfect fit for our you can say problem, and then we will create a front end and a class a web application for this project deployment. I will see you tomorrow. Okay, bye bye. Have a great day.